Good morning, everybody. So yesterday we started talking about structures, and we are going to continue with classes today. That will be the first time that we will be covering classes in a formal way. We talked about them, but we didn't really tell what they are and why we are using them. Okay, so let's look at our first structure example. Actually, I am going to show you where is my divs. Okay, here it is. No, it has crashed. I think it has crashed. No, it is doing something. Okay, so let me open this up again. So this is yesterday I gave you this example. We have a struct CD account version 1, cash dividend account, or vadeli hesap in Turkish. I have two doubles and one integer in it. As we said, structs are aggregate data types, but like the arrays, but the difference is the data inside the struct can have different variable types. In this case, we have doubles and integer. That's one difference between structs and arrays. Okay, and we have a function get data here. This get data is a void function, but it works on a CD account object, CD account variable. Okay, so different from C. Let's look at this line 19. In C, we used to say struct, okay, CD account v1 account. No, we don't do that anymore. We just say that, okay, I have a type, new type, its name is CD account v1, and account is a variable of that type. Okay, that's why I am passing a CD account variable by reference. This means it's a reference, right? By reference, and this is a simple function. It will take it, and as the explanations, as the commands say, you get the values from the user, from the keyboard, and return whatever you have read from the user. Okay, get data. And then what I do is I just make a new object account. Okay, and I send it to a get data function because I am sending it by reference. It will be changed. Then I am defining two things: rate fraction and interest. Rate fraction is this much. Okay, account dot interest rate dot operator is an operator. Okay, it is used to access the members of structs. Also, we are going to use it for the classes and objects too. And I divide by 100, so it's a rate now. It's a fraction, and the interest, that is faiz in Turkish, will be calculated by this. Okay, account dot balance times rate fraction times account term over 12. 12 is the month. Okay, so I am just dividing the term by 12 to get the yearly interest, I guess. And then I am updating this account dot balance, and I'm printing these out. Okay, so the function itself is very simple. All it does is reads these 1, 2, 3 struct fields or struct members from the keyboard, and that's it. Okay, so there is nothing new other than the declaration of the struct objects or struct variables here. Other than that, there is nothing new in this slide. We already know about this call by reference syntax, and nothing should be surprising in this program. Okay. Any questions on this program? So this program is not written the way I want it actually. It would have been better if they did this. Okay, get data and print data. Okay, print data will get this account, and since I am not going to change the data from the print data, I am going to put a constant here. I don't know why I couldn't const. Okay. So I am sending this account with call by reference because it's a large data structure. It's a const because I don't want to change it. So I am not doing any copying of the whole structure, and I don't have any risk of changing the data inside this print data function. Let's start this from the back so that I can. Okay, and I can easily implement this, right? Implement this. Very similar to not this one, not that one. I think I found it. Yeah. Okay, all I'm going to do is just get these out and put it in here. Okay, so the account, and these are the account. So I am going to, I guess, do some search and replacement here, right? I don't have Control H, edit. Do you see it? Replace. Where is replace? Search. Yeah. Okay. Replace. Replace her. So I am going to find all. Why don't I make this account then? Yeah. Good. It should work, right? It will print the things out. It will calculate everything, and I'm going to repeat this line, and this will be print data. Okay, so it's very clear. Okay, the code, all it does is it has this account. All the data related to account, cash dividend account, is inside this struct, and I get the data from the keyboard and I print all that data to the screen. So it is very well abstracted, right? When I read this code, I don't have to think about, I forget about this field of the data, etc. Because I know that get data and print data is, something that can handle all those details. All I'm doing is that I'm calling those functions. But the thing is that those functions are global functions. Anybody can call them with any type of account information. In object-oriented world, we don't like those kind of functions because we like our functions to be part of the data. Okay, to be part of the data, and whenever we call those functions, we like to have a picture like this. Whenever I call that function knows what kind of data it works on. Okay, so that's the difference between classes and maybe structs. Okay, so with this struct, I put together all the related data. Okay, with these two functions, I kind of abstracted the procedures about that data. But these two functions are, again, as I said, they are global functions, and we don't like global functions much, and we are going to see it in a few minutes how we can change that. Okay, so clean code, all the data are hidden inside the functions. All the data is collected together. By the way, I didn't have to define this struct. I could have defined this balance, interest rate, and term as separate variables inside my program, and without using the structs, I would have been fine, right? I don't need the struct to make a working program. But if by making this a struct, there are many things now I can do in an easy way. For example, I can say I have a account array, right? I can say I can have an account array, and its size is 100. Okay, so I know that I have 100 account variables, and each of them has balance, interest rate, and term in it. Okay, so I know this one too. So it is very easy for me to make these kind of small code. You write small code, and that small code has lots of meaning, and I know that everything. I will not forget any information about one of these fields. So these are the nice properties of the structs. Okay, good. If there are no questions, I will go to the beginning of the slides again. This is our CD account V1 class. Again, 3 fields in it, 3 data members in it. Declaring a struct variable is like this one. Okay, you say this is my struct type, and this one, the second one, is the variable, and that's it. Okay, how do you access? It says my network quality is bad. Do you guys are hearing me okay? Online people?
Not good, sir.
It is okay, it is not bad. Do you hear me right? You don't
It's real bad.
You don't hear me at all?
Your voice is breaking most time.
Okay, let me. Yeah, I am connected through Teams. Let me turn off my video. Maybe that will make it a little bit better. No. How about now? Is it? Did that make any change? Well, anyway, I cannot do anything about this now. I mean, you can after the class. I will upload the video. For the parts that you are missing, just watch the video. Okay, so accessing the structure members is by this dot operator. We already know that, and we looked at this program previously. And in fact, I changed this one right to something else. Okay, so with the structure, yeah, this is something very. You might say that this is a very small detail. Why are we talking about this? But this is important. When you define a struct, okay, you put a semicolon at the end. Okay, you put a semicolon at the end. This is important. Why? First of all, if you don't put a semicolon at the end, you will get a syntax error. But why do I need a semicolon? I mean, I don't. When I define a function, I don't put a semicolon at the end, right? When I define a function. Why? It is almost like defining a function. The difference is, of course, it's not a function. I don't have the parameters and etc. I mean, the syntax-wise they are similar, but why am I putting a semicolon here? Because that semicolon means that I am not defining any objects of this struct. So it is possible to have. A1, A2 here. So if I do this, I will have two global struct variables. Names are A1 and A2. Okay. So it is possible to have variable names with the definition of a struct. And if you don't put any variable names in there, that means that I am just defining a struct. I am not declaring any variables of the struct. That's the reason why you put a semicolon at the definition at the end of the definition of a struct. Okay. Yes.
What's the difference when we initialize them in main or in struct?
You mean if I do this, where would I initialize them?
No, like saying we have a variable, but what's the difference with main and doing it there?
Oh, you mean what is the difference defining a struct inside the main or globally?
No, the variables.
The variables?
Mm-hmm.
Well, this is no different than declaring an integer here, right? What is this character? How did I do that? What is this? I was trying to make an I. So at line 13 I declared an integer, global integer, and this global integer is valid after line 13 in my program file, okay, in any functions. It's a global. So if I do this A1 is a global variable of type CD account, and it is available anywhere after this line 11 inside this program. That's the difference, global versus local. But we don't like globals, right? In C++, we don't like globals because we have no control over them. If there is something wrong with that variable, it is very difficult to find who made that change. Okay, did I answer your question? Okay, good. So we talked about this, and let me go back. And this is important that we will talk about. Okay, mark this slide, slide 10 of this chapter 6 or your book. This is one of the most important differences between Java and C++. You might say that is that semicolon is so important? Yeah, it is so important. This is one of the most important differences between Java and C++. And we are going to see why. And in Java, they don't put semicolon at the end, okay? Because they don't have to. They don't have to, okay? And why they don't have to put this semicolon is the main source of the difference between Java and C++. And remind me if I don't talk about it when we start talking about Java. That will make things a lot clearer to learn what this Java is all about. Okay, structure assignments are allowed. Yeah, they are fine. I can. Let's say I have a struct named crop yield. Okay, crop yield. Hasat miktarı in Turkish maybe. So crop yield is the struct type, struct name. Apples and oranges are the variables. I can do this assignment. As long as the struct types are the same, I could do those assignments, okay? So let me write this here. Let me write one example here. Struct, let's say struct, just make a stupid name A, integer I, and string S. There is a one struct here, okay? And if I have two variables like this, I can do the assignment, no problem. But if I have a struct B, it has exactly the same definition inside string S. Okay, let me make two B1 and B2. Okay, as I did in here, I can of course say B1 gets the value of B2. That's okay. But I cannot say this. This one is okay, this one is okay, this one is bad. You might say that their contents are exactly the same, one integer and one string. Why can't I do that? C++ or C don't care about what the internals are. The important thing is that, okay, they are two different structs. So as long as the types are the same, I'm not talking about the equivalent. As long as the types are the same, then I can do this assignment. So the assignment operator works for any kind of structs. What else works other than the assignment? I think we talked about this. Other than the assignment, what kind of operators work? Let's look at these green ones. Okay. Yeah, dot operator works. Dot operator, but stream insertion doesn't work. Okay. Assignment works. Equality doesn't work. Okay. Size of works. Taking address of a struct variable works. The pointer of a struct works, and of course the arrow operator with the pointers work. Okay.
İki kişi yok hocam.
What?
İki kişi yok hocam.
Thank you. So it would have been nice if I had an operator like this. I mean, A1 less than, if A1 is less than A2, okay, then print out A1. Or A1 gets the value of A2 plus A1, okay. So if these operators were available, it would have been very nice, but they are not available by default. That doesn't mean that they won't be available. By overloading these operators, we will make them available for our use. Okay. When you define a struct, the definition of assignment is already known. Okay. So what is the meaning of the assignment here? When you say A1 gets the value of A2, find the starting of address, finding the starting memory address, starting value of the address of A1, and the memory address of A2. You know the sizes of the structs, right? How many bytes? Do a mem copy between those two addresses. You remember mem copy, right? From C. Just do the mem copy. Let's say both of them are 20 bytes. Make a 20 byte mem copy, okay? That's it. That's the meaning of the assignment. But how about the meaning of the less than sign for this account class, struct? We don't know. I mean, it is user defined. We don't know how to compare. How would you write the comparison function for these two accounts? Would you compare the balance? Would you compare the interest rate? I think I would compare just the balance, right? If you are comparing two struct objects, two struct variables, I would just compare the balances and that's it. I don't compare the rest. And I compare them as doubles, of course, right? So using something like comparing each struct value byte by byte, okay, using mem CMP, that doesn't work. So the reason why those operators are not available because there is no meaning to less than or greater than or equal to, okay, is equal to stuff with new types, so we have to define them ourselves. Okay, good. We talked about this. Structure assignments, we talked about them. Okay, structures as.
Sorry,
Yes,
can I ask some?
sure.
Yes, in CPP, can we assign variables values in variables in structures? Assignment. Can we assign
Sure,
values?
Sure, that's what we did here, right?
Variables.
Isn't this what we are doing here?
Structures.
I mean,
Okay.
you are saying that can I do A1
Inside structure. Inside the structure.
do you mean can I do A1 dot balance is 7.0? Is that what you mean?
No, in defining.
You mean that can I initialize them?
Inside the struct.
Okay, this is not called assignment. This is called,
Yeah.
okay,
Struct.
like this. Can I initialize them in here? In C++ 11, yeah. In C++ 11, yes. In C++ 98, no. Okay. We will talk about this when we start covering classes. Okay. So what you are saying is,
Okay.
it is not variable assignment, it is initialization. Initialization is very different from assignment. And it is important to know the difference between them to write efficient and sometimes correct programs. Okay, so structures as function arguments, all of them are possible. Pass by value, pass by reference, or combination. Here, a function f taking a CD account v1 variable called by value. Here, a function g that takes a CD account v1 by reference, but it's a constant reference, like I did before. And here is a function h. It doesn't look like h. Let me try to make it look like h. Function h. It takes a CD account v1 pointer. So probably it's going to do simulated call by reference over this pointer. Okay, so all of them are possible. So the thing is that maybe I repeated this many times. I am going to do it again. Struct variables are no different than integer variables. Okay, whatever you can do with an integer variable, you can do it with the struct. Of course, I mean, if you are adding to integers, that doesn't mean that you can add to struct variables, because addition operator is not overloaded for the structs. But as you know, whatever I can do with a pointer, I cannot do with an integer. For example, this is valid for a pointer, the referencing operator, but this is not valid for an integer, right? So, I mean, so each type has its own operators defined, valid operators and invalid operators. And the same is valid for the struct. So the basic idea is struct variables are no different than any integers or doubles or pointers, etc. So there are things that you can do with them, there are things that you cannot do with them, and the differences are defined by the CC++ standards. You can also return structs from functions. You can either return the value itself, or you can return the pointer to a struct, or you can return a reference to a struct. No problem. Okay. Good. Initialization of the structs. Okay. I have a struct, and I have a struct object or variable. I can initialize this variable this way. This is, you already know this, right? This is like, this is no different than initializing an array, right? Arrays are initialized this way too, right? So when you declare the object, you initialize it. As our classmate asked, can I initialize them inside this? Yeah, you could, but it is not a backwards compatible initialization method. So try to write your C++ 98 code first, okay? Make it 98 compatible first. If you have to, then use C++ 11, because you will never know what kind of compiler you are going to use next time. You need your reusable code, okay? But just to make it C++ 98 compatible, if you have to write lots of code and etc., maybe it is not worth it. Use C++ 11, okay? That's why we kind of are very cautious about using the newer standards, because we don't know if those compilers will be available to us in our next project. Okay, that's one thing. Then the second thing is, if those features are not accepted much by the community of C++, maybe our code will not be that compatible. Maybe our code will not be that reusable. That's why we keep using old standards. Okay. Do you know the equipment they use in Mars explorers, those rovers that they are sending to Mars, they use at least 10, 15-year-old technologies in those rovers, especially the cameras. The camera resolutions are like one megapixel, 2 megapixel cameras, right? Because they know that they work. Okay, they have tested it. Okay, there wouldn't be any problems while those cameras are working in space. It is tested, well tested. Okay, it is not that difficult to put a 50 megapixel camera on that device, but that technology is new. They don't know what kind of problems it's going to see in a few years, right? So this is not exactly the same, but this is similar. If you use old and not outdated, but old, proven, tested compiler versions, C plus versions, you will be safe. Of course, the downside is you are not using the latest technology. That's the downside. Okay, so this is how you initialize your struct members. Month is 12, day is 31, year is 2003. Okay, so this is struct date. We already know that. Okay. Now we come to classes. Okay, classes are not that much different from structs. I mean, that's why we have been talking about the structs. Okay, similar to structures. Now we are going to add our member functions. Okay, not just data, but also we will have member functions. So those member functions will work on the data. Will work on the data, and whenever we call them, okay, they will perform their functions. Those functions are not global functions. These functions belong to these structs. Okay, let's look at this simple struct definition. I bet you did some rational structs. You wrote some rational structs in C, right? Did you do that? Rational numbers, rasyonel sayılar. Why do you know why they call it rational numbers?
Ratio.
It's because of the ratio, right? It is not because of the rationality. Okay. Gerçekçi, it's not gerçekçi sayılar. It is rational, kesirli sayılar, right? So it's a rational number struct. So rational numbers, they have two integers a and b. So this is numerator and denominator, a and b. Okay, usually what we do with the rational numbers, we print them, we add them, etc. Okay, so I put a print function in it. I didn't implement it yet. I put a print function in it. I am not going to show the implementation yet, but just to show you how the things work. Okay, when I say rational R1, now I am initializing it with 1 and 2. And when I call this print function, R1.print, I am expecting it to print 1 over 2 on the screen. Okay, this is 1 over 2. It's not 111, 12. Okay, this is 1 over 2. Okay, and if I have other maybe member functions, it would be possible to write this kind of stuff. R1 dot add R2, and the result will be assigned to R3. Okay, so what kind of things I need to overload? What kind of things I need to write as functions? Add function, print function. Assignment is already there. I know that. Okay, so these kind of things are already available. Let's look at this function print. As you see, it doesn't take any parameters, right? It doesn't take any parameters. Where is the parameter? Where is A and B? Okay, it is in here, right? This is kind of parameter, R1. Okay, so this print function has everything it needs to work on. Okay, it has everything that it needs to work on. It has access to A and B, and it can print, or it can do whatever it wants about A and B. So that's the idea of classes. Actually, classes are not any different than structs. The main difference, there are some other differences we will talk. The main difference is you put your data along with the function that work on that data. Okay, so that idea is integral to object-oriented programming. I am sure you all are kind of surprised that is this the fundamental building block of an object-oriented programming language? Yeah, the answer is yes. Yeah, that's the fundamental building block of object-oriented programming languages, and that's how we do that. We put the data, related data, along with the functions to work on that data, and inside the same programming structure, and we call them classes. Okay, we call them classes. Okay. Good. Let's move on. This will be a little bit clearer, and we will keep discussing about this kind of an idea. Why is it better than pure structural programming languages? Remember the structural programming languages? You can write a program by stacking blocks, by nesting them together, and by writing the control structures together like that. Okay, building blocks of the structured programming language. You know that. Object-oriented programming languages, they say the same thing. Okay. Use the structured programming language techniques, yes, that's true. But the more important thing is that you will write proper classes. Okay, in C++, this is called a class. I mean, it's like code class. And this is an object. We are not going to call them variables anymore. We are going to call them objects. This is a class. This is an object, okay? This is an object. From the beginning of the semester, I use them kind of interchangeably, objects and variables, but usually if you write a class and if you make a variable of that class, it is called an object, okay? So object contains data and operation, etc. So let's see our first class, okay? To represent a class, instead of using struct, we use keyword class. Okay, this is okay. This is syntax-wise, no problem with this. This is a struct. It looks like, okay, it looks like a struct, but inside it there is function. If you are going to use functions inside your structs, then we call them classes now, and this is how you define a class. It's like a change this class to a struct, and then you should be fine. But it is class. Day of year, I defined it. And at the end, I have the semicolon. It is exactly the same. Let's ignore this keyword public for now. Don't see it. Okay, don't see it. And this is the elements of our day of year. Day of year means I am going to represent any day of a year by its month and day. And as you see, I have a function named output. That output function, as the name implies, will print the values of the value of day of year, okay, value of day of year on the screen, okay, and it looks like I am just giving the prototype of the function. The implementation is going to be somewhere else, and we will see the implementation. Implementation is not, as you see, the implementation is not, as you will see, the implementation will not be that detailed. It will be easy, just printing two values on the screen. Okay, let me move on. And this is how you define the objects of classes. Day of year is the class name. Today and birthday are two objects of this class. It's no different than doing this integer I and j. I and, let me make it a dot, make it a comma, okay? I am defining two integers here, I and j. I am defining two, okay, day of year objects, today and birthday. These are objects and these are the classes, okay? And inside the data, I have my members month and day. Also, inside my today and birthday, those functions are available too. So after doing this, the day of year, today and birthday, I can say today dot output. Okay, now I call the function output on today. Whatever the content of today is, this one will print on the screen. It doesn't print it automatically. Of course, somebody has to implement this output function, and we are going to implement it in a few minutes.
Sorry, when are we going to take a break?
Say it again. I didn't get what your question. Did you have a question?
When are we going to give a break?
At 15, 10, 15.
No, not regarding to. I'm sorry.
10, 15.
Oh, okay, thank you.
Did you ask when are you going to give a break? It is 10, 15. Okay. We are doing 45 minutes of classes and 15 minutes of breaks, okay? Okay, let me show you a program about classes. Where can I find them? Okay, this is not that's not it. Let me load these up. This one. Yeah, okay. So, day of year class is this. Is this visible from back? Is this visible? From the back, is this visible? Is big enough? Okay, so include a namespace, etc. Day of year class definition here. Okay, I have two day of year objects, and as you see, I can access the data members just like accessing struct members, right? I ask the user to give me a month number, okay, I get the month and I enter it. I ask the user to give me the day, I entered it, okay. And this is for today, and this is for birthday, today and birthday, okay. Now I call the output function on today, and I call the output function on birthday. And then I am doing this, okay, and then I am doing this. If today's month is equal to birthday's month, and if today's day is equal to birthday's day, I will print out happy birthday. Otherwise, I will print out happy on birthday. Okay. Good. Okay, so that's the main function, that's it. And the implementation of this output will come like before, after the main. This is how you implement a class member function. This is not a global function. That's why you will say, I am declaring a function, it will return a void. Name of the function is output, but it's a function of the class day of year. Okay? So day of year is the class name. This is binary scope resolution operator. Scope resolution operator. Okay? You use the scope resolution operator to indicate that you are working on a function that is a member of a class. Okay? And after that, I am writing a regular function implementation. Of course, the only difference is when you look at this code, I mean, as a C programmer, when I look at this code, line 46, when I see this month, what is this month? Is this a global variable? I mean, it looks like a global variable. Why? Because it's not a local variable, right? It's not a parameter. Where did it come from? I don't have a global variable named month. Well, remember, we call this function output, okay, on day of year objects. So when somebody calls today.output, okay, this month is inside this today. If they call birthday.output, this month here, okay, is inside this birthday, okay. So usually for the object-oriented programming languages, when you call functions, those are usually most of the time functions of the classes, and usually you don't see that many parameters. Those functions don't need parameters much, because all the data that they need to work on are already inside the classes objects. Okay, so they already have access to it, and everything is happening automatically. You don't have to pass lots of parameters around, which is a good thing because it makes it easy to write. Also, it makes making mistakes a little bit more difficult. You don't have to, I mean, you cannot give wrong parameter names or the wrong parameter types and etc. because this one doesn't take any parameters output. Okay, any questions? Yes.
Hocam, sorry, do we have to introduce those member functions in the beginning of our code, or can we do it?
Well, it is no different than writing a global function. How did we write the global functions before? Like this, right? I said that this is my struct. Okay, this is my global function header. Global function header. I use them, and after the main, I introduce the implementation. This is kind of similar. I am saying that, okay, this is the header of my member function. I am using it in my main, and later I am implementing it. This is no different than writing global functions. Of course, it is not a global function. Okay, good. Any other questions? Okay, let's take 10 minutes of break. Let's be here around 10:32. 10:32.
Kopuyla şola tam olarak
Anlayamadım.
kopuyla şola.
Anlatmadım ki ben öyle bir şey.
Yok. Yani çalışıyorum.
O hemen 2 dakikada anlatılmaz ya.
Ama tamam.
Yani
Struct'ları mesela ben kopuyla atarken aslında bir kopya yapmış olmuyor.
çok da değil yok. Shallow copy'de eğer pointer varsa elde pointerları tartıyoruz, onları kopyalar. Git copy'de onları kopyalaman lazım. Eğer pointer varsa elde. Oradan pointer'in kendisini kopyalıyorsan shallow copy yapıyorsun. Ve biz pointer'dan falan filan hiç bahsetmedik şu anda.
Çok iyi.
Ne zaman geldin?
15 dakika falan oldu yani.
Ha?
15-20 dakika oldu.
Geç kalmışsın. Arkadaşlar sınıfı boşaltalım ya. Şu camları da açalım. Havalansın. 15 dakika arayı sınıf havalansın diye veriyoruz. Sınıfta beklemeyin, olur mu?
Lan ne olacak ya? Allah Allah yansın ya orada. Allah Allah. Lan. Dedim ki gelmesi az kaldı ya. Saçma.
Şarjım varsa bakalım.
Sürekli bira basarak bir sonraki şey yapıyorum. Bira bas kontrol, bira bas kontrol.
Şeyler, kadınlar falan istiyor.
Üçgenden mi bahsediyorsun?
Okay, so we must define or implement the class member function. We already did that. And you have seen this, right? Okay, this is scope resolution operator. And we use it mainly to separate the class name from the function name. In this case, there are some other uses, and we are going to see it later. Okay, so this means that, a class member function is defined very similar to a regular function, but it's not a regular function. It's a part of the class. That's how you say it's part of the class. Okay, so we talked about this. Refer to member of. When you refer to the member of the classes, remember to access the previously to access the struct data members. Okay. To access the struct data members, we used to say account.interested in, etc. But within the functions themselves, for example, when you say get date or when you say cd data, okay, they account that initial balance and etc. But now in our output function, I don't use such a qualifier, such a struct name, because I am already part of this struct. When I say month, the compiler knows which month I am referring to. Okay. So that's something to remember. By the way, let's go back to this definition. Okay. Day of year, today, and birthday, including this definition here. Okay. Let's look at the memory, what's going on with the memory. Let's try to draw it. When you say I and J, the compiler will allocate space for two integers, 4 bytes here and 4 bytes there. Okay. When you say day of year today, okay, compiler will allocate space for today. So this is my today variable, today object. But inside today, I have two integers. One of them is month, right? The other one is day. And inside birthday, again, birthday, I have two integers, a month and day. Okay, this is how the memory looks like. You might say that what happened to the function output, because day of year objects contains, okay, they contain two integers and there is a function too. Well, I don't have to repeat the function because the function is there is only one function, the output. Okay, that function is the same for all the objects, because when I call that function, okay, when I call that function on today, that function works on these two integers. When I call that function on birthday, it will work on these two functions. The function is the same, function doesn't change, but of course the data changes from objects to objects. Okay, it's like you don't see any plus operators or minus operators or the assignment operators inside this integer I, right? So those procedures, those functions are common for all the integers. Okay, the data changes from integer to integer. So the data changes from today to birthday, but the function output is the same. Okay, so don't get surprised. And when I say what is the size of today or what is the size of birthday, it will be the same as two integers. Size of two integers is the size of today. Okay, you can ask this question to the compiler. What is the size of day of year, the size of today, or the size of birthday? And the compiler will give you the answer. Okay, good. So we talked about this, so we don't forget about it. Okay, so class member definition, we talked about them too. And this is the example, exact example. Oh, okay, here it is. Today and birthday are two memory locations, and they have two data members in them. Okay, good. Data and scope resolution operator I already talked about. Okay. And let's talk about this class a little bit more. Because
Can I ask something?
sure.
When we
There are
declare-
other people inside the classroom. It's not you and me only. Okay.
Okay,
Say it louder.
when you declare them like that, where are they stored in the memory? In stack or heap?
Well, if they are, the question is, when we do this declaration, two integers and two day of year objects, where are they stored? In the stack or in the heap, or where are they? It depends on where you declare them. I mean, it is the same as integers. If you declare the integers in the local scope as the local variables of a function, they are placed on the stack. Okay. So the rule is very general. I mean, whatever happens to integers, whatever the rules are for the integers, it is the same for the day of year objects. Okay. So wherever the integers live, they live at the same position, at the same place. So if we are a global variables, then they are on the heap. If they are local variables, they are on the stack. If they are dynamically allocated using malloc or something like that, they are on the heap again, etc.
Thanks.
Yes.
Is it possible to make member functions parameter from outside of the class?
Is it possible to make the member function what?
Member functions parameters outside the class?
Member function, I'm not getting that word. Member function what?
Member functions parameter.
Parameters. Is it possible to define member function parameters? Is that what you are saying?
Yes.
Yes, of course. I mean, member functions are like regular functions. It has a return type, it has a name, and it can, of course, have parameters too. But usually, most of the time, they don't need parameters because they need all the data from the object itself. When I say today.output, this function output has all the information that it needs from this object itself today, right? But sometimes it needs extra data. Of course, for those cases, yes, you can have parameters as regular global functions. You may define them, and we are going to do it. Maybe not today, maybe tomorrow. Okay, good. Any other questions? Okay, we talked about these. I am not skipping anything. Well, if I skip anything, I will go to the program again. And let's again talk about this class's place. What's a class actually? Okay, a class is a full-fledged type. Okay, it's like regular integer, double, etc. It's a type. Since it's a type, it can have its own variables or objects. Okay, and these class types can have variables, but we call them objects. And these objects, class objects, like integers, okay, they can be sent to the functions by call by value, call by reference. You can take their parameter, you can take their addresses, send their addresses for simulated call by reference, and etc. And they can use the class type like another type. So this is one of the promises of C++. I mean, I am going to treat your new class objects like I am treating integers. Okay, with the integers you have operators defined, and I'm going to let you overload those operators. With the integers, size of works and size of will work for your new class objects and new class names and etc. So your class will be a new full-fledged type, and the compiler will recognize it, and it will be no different than using an integer. Okay, so that means that integer is a very nice variable type, very nice class. It is very reusable, and we use it all the time, everywhere. Okay, So your new class will be, if you design it right, if you implement it right, it will be very similar to integer. It will be as useful as the integers are. Okay, that's what the promise of C++. And for this, C++ will ask you to follow some rules. One of them is the encapsulation. Okay, this is one of the basic principles of object-oriented programming. I mean, don't be scared about this nice fancy name, encapsulation. It simply means putting all the data and related functions inside the same capsule. Okay, you encapsulate them inside the same capsule, and we call them classes. Okay, any data type includes the data and operations that work on data. We use this idea with the integers. Integers has the data. The data can represent numbers from, for a 4-byte integer, of course, from this number to this number, and the operations that work on this integer are these operators. Okay, those are the operations that work on this class integer. Okay, same with the class, but we specify data and the operations to be allowed on our data. So this is, in a way, when you write a class, you are following this encapsulation principle. You put the related data together and you include all of the functions that needs to be used on those data. Okay, and no global functions are allowed. We don't like global functions. Whatever function you are going to call, it should be part of a class. That's what we are saying with the object-oriented programming, in a way that everything has to be encapsulated. Okay, I don't want to use with a global function like f. Like f, the function f by itself doesn't make any sense. You need to pass some parameters, right? So those parameters are usually some local variables, global variables, and etc. So this function needs data from the outside world. Okay, global functions. But when you write member functions for the classes, usually those functions, they don't need any data from outside world. They already have their own data. So they perform in a controlled way on that data only. And if nobody has access to the data other than those member functions, then I have a very controlled environment. Okay, I know what I am doing. I know who has access to all that data. If there is something wrong with the data, it is my job to fix it, and I am responsible from it. No global functions can interfere with my data and etc. So it makes writing program a lot easier, maintaining them a lot easier, doing the teamwork a lot easier. So these are all the consequences of encapsulation. Okay, with the encapsulation, there comes this idea of abstract data types. Okay, in the abstract data type, the programmers don't know the details of your data. Okay, you have been using vectors for the last 10 days maybe. Okay, but you don't know the details of vectors actually. You don't know how the vectors keep the data in the memory. Okay, you don't know how that function pushback works exactly. You may have some guesses, but you exactly don't know how it works. And that kind of information is not made available for you. Okay, it is hidden. So the idea of vector or list is very simple to understand, and all the details are abstracted away from you. Okay, so that vector or list is an abstract data type, or ADT. We have vectors in C++. We have vectors in Java. We have vectors in C#. We have similar data structures in all the object-oriented programming languages. Okay, they behave the same way, but their details might be very, very different. So it is very easy for you to understand what vector does in Java or what list does in Java, because you abstracted away the details of them. Okay, so we are after writing these kind of data types, these kind of classes where the interface is very clear. Okay, you understand what the interface does, but you don't have to know the details of the implementation. And ADTs are often language independent. We don't say stuff like, okay, this is only available in this language, etc. No, the list is a double linked or single linked list, or stack, or queue, or vector. These are all available in different languages, and they are used the same. They are used the same way actually. Okay. So abstract data types. You are going to spend all of next semester for your data structures course about this abstract data types. Okay. That's why you are going to use an object-oriented programming language for that course. This is Java. It's going to be Java. That way you will get used to Java ways of doing things, but you are going to keep the idea of object-oriented principles always in your mind. Okay. Encapsulation, again, encapsulation and data abstraction, or the abstract data types, are two very related things. By following the encapsulation rules, you are basically writing abstract data types. You have a question? Yes?
Can two different classes access same function definition?
No, they cannot share the same functions. If they are not related classes, okay, if they are not related, they cannot share. There is a way of relating two classes, like the parent-child relationship, ancestor-descendant relationship, when we come to inheritance. In that case, yes. But if two classes are not related, they cannot share the same function. Okay, and it will come later. Okay, it will come later. So you have to specifically say that these two classes are related. They are coming from the same root. Okay. So again, more encapsulation. Encapsulation means bringing together as one, putting everything inside the same capsule. What are those things? Data values and operations on that data, that is the member functions. And these are some of the principles of object-oriented programming. Okay, they are all related. There are a few other principles of object-oriented programming. It will come from time to time, but for now these three are enough. Okay, one is information hiding. Details of how operations work not known to the user of the class. You hide information, okay? You hide as much as you can, okay? Try to hide everything that is not useful for the user. Hide everything, okay? That's one thing. Data abstraction, details of how data is manipulated within the abstract data type not known to the user. Of course, these two are very related. Details of how the operations work not known to the user. I mean, this information hiding could be in terms of how the functions work, also what kind of data we have in a class, okay? We hide that information. For example, you don't know how the resize function works for the vectors, right? But you also don't know what kind of data I keep inside a vector, okay? I know that it is like an array, but I actually don't know if they are using a regular C array or something else. Okay, so information hiding is more general than data abstraction. And encapsulation means, okay, encapsulation simply means structs with data and functions together. Okay, we keep the data and operations together, but we keep the details hidden from the user. So that's basically the object-oriented programming. That's it. Okay. So you write classes that follow these rules, especially encapsulation. So that means that you started doing some object-oriented programming work. I see some people, okay, using the C++ compiler to write some code using the C++ 11 rules, for example. The classes they write, okay, they are not following these rules. They keep writing lots of global functions too, okay? So they think that they are doing object-oriented programming. In fact, what they are doing is writing straight C code, okay? So the fact that you are using a G++ compiler doesn't mean that you are writing object-oriented code, okay? Writing object-oriented code is not writing C code. If you keep writing C code, C techniques of doing things, then you are writing in C, which is not bad, but it is not object-oriented, okay? To write object-oriented programs, you have to write classes, reusable classes, okay? classes that are examples of abstract data types, classes that obey the rules of encapsulation. In that case, we are writing object-oriented programming examples. Okay, so let's talk about that small keyword that we ignored for now. Okay, remember that keyword? You have a question? Remember that keyword somewhere. Where is that keyword? Yeah, day of your this public. Okay, we will talk about this, and we are going to introduce another keyword, private. Okay, another keyword, private, which is just the opposite of public, and we are going to look at the meanings of them. But before that, am I missing anything? Yeah, this is struct. This is one struct. Oh, okay, this is a good example, right? This struct is using another struct in it, right? There is a date struct. It keeps the year, day, and month information of a date. Nice. There is the CD account. It keeps the initial balance, interest rate, term, and the date of maturity. This is, in Turkish, I think you would say vade tarihi, right? Vade tarihi. And this is balance at maturity. Maturity means this vadesi dolmuş, I guess. So it's a new struct. It keeps all that information, but some of the information is another struct, which is a common case for us. Nice example. Okay, and I have two functions, global functions. It takes a CD account and it takes a date. It looks like both of them are going to modify whatever they take. Okay, so let me see. I am guessing that this get CD data will call this get date. Yeah, is that correct? Yeah, get date. So get CD data calls this get date, which is kind of, yeah, makes things a little bit easier, because when I'm designing this struct, I don't have to think about the date anymore, because all the details about date is handled by this struct date, but the functions are different. If I had classes instead of structs here, okay, this date class would have come with its own functions, such as print date or get date or compare dates and etc. Right? So it would have been easier to write the CD account class using those functions. Okay, here, did I miss anything? I think we already talked about this day of year class. I have two of them. I get this, and day of year output is this. Let's in a hypothetical world, okay? Let's look at what this program does. I have two objects of this class, today and birthday. So what am I doing here? I am inputting these values from the keyboard, right? So instead of doing this, it would have been much nicer if I do just this. Yeah. So it would be get this out, and yeah. C in stream extraction today. So I get the today's values from the keyboard input, right? And do the same thing here. C in birthday, and get rid of these. And how about this one? I would say C out today, right? And then get rid of these two. I think there is a way to comment these out, right? Intent, yeah. Good. And this one, instead of calling just output, I would just do dot, no, I like to do C out. Okay, good. Much better. How about this one? How would you do this? How would you write this? Instead of doing this, I like to do this much more readable way. How would you do this? Some hint for you. It will start with it today, and then what?
Today is equal to workday.
Today, right? That's it. So this would be a much cleaner code than what they are writing here, because I am using the stream extraction operator to get today, stream extraction for the birthday, stream insertion for today and birthday, and comparison operator to compare these two. Okay, so we are going to write them one by one, but in fact we don't know how to overload the operators. But how about this? I like to write a function. I can write it right now. Today dot equals okay, birthday, right? Okay. I am going to write it this way. So I think one of you asked this question, can I have a parameter for a member function? The answer was yes. Let's write this function actually. So if this function returns true, then it will do this. Otherwise, it will do the other one. Let's write this function. Equals is a okay. Equals. What kind of value should it return? Equals. It should return a Boolean. Well, equals cannot work by itself. When I say today dot equals doesn't work, right? I mean, what is it? How am I compared to? How am I compare myself with anything? Okay, so it needs some extra data from outside world. So, what kind of data it needs from outside world?
Day of year.
Another day of year object. Okay, let's write day of year object. Okay, since day of year is a class, it is large. I am going to, if I can find, okay, 6, right? I am going to take the other object. Since this is a call by reference, I don't want to modify the other object. I will pass it by a constant, okay? So this is the header for the equals function of day of year class. Okay, it will return a Boolean. Good. So by looking at this, it looks like my way of calling this is right. Okay. So who asked this question? Did you ask this question? You asked this question, right? Can member functions have parameters? Yes. And this is the parameter, one example parameter. I am just taking another instance of the class. Okay. So let's implement this. Let's implement this function here. It will return a Boolean, but this is not a global function. This is a day of year equals. Okay, so these kind of editors are nice. As soon as I write day of year binary scope resolution, it say that which one do you want, this one or that one, Okay, I already had written it. Okay, and is that, no, 6. What was the curly bracket? Oh no, this one, yeah, this one. I will find it. 6, 7. Which one is the curly bracket? 7? Yeah, 7. Okay, so tell me what should I do?
We will
Maybe
check the
if
data.
what?
We will check if day
Day of year,
and month and the year, if they're all equal.
Yeah, but what should I write here? Month and day, right? If my month is same as what? Other dot month. Okay. If my month is same as other dot month, and if my day is same as other dot day, then return true. Otherwise, return false.
You can ask something.
What?
Is it a bad practice to just straight return the above expression?
Yeah, that would be the advice. I'm trying to write it in a more
Okay.
easy to understand way. Okay. So this is how I implemented it. It's kind of, we had never written functions like this. It is talking about when I'm talking about myself, I talk about month and day. When I talk about the other objects, month and day, I need to refer to their first name first, because there is this other object. I am talking about the month of the other object. Okay. So when this function is called equals, it is called on today dot equals. Okay. In that function, when I say month is the month of today. Okay. When I say day is the day of today. Birthday becomes other. Okay. Birthday becomes other. So other is a very good parameter name here, because this as I have myself and the other. Okay. Good. Any questions on this? Try to write this yourself. I am sure you will get confused. It is not easy to write this in the first try. You don't remember what is going on, what kind of parameter should I get for my function. But after a few tries, you will get used to it, and once you get used to it, you will see that this is a very logical way of writing functions. Okay, writing not global functions, but writing member functions. Okay, what kind of other useful member functions do you think there are? Useful member functions? Another Boolean for me, okay? I think it is less than. Less than would have been a nice function to compare to day of year objects, to sort them, right? Maybe. So what kind of parameter would it take? It's the same thing, right? The other. So I would take another one. Okay. What else? I like to write a function that returns the next day. How about this one? Next day. It's going to return the next day. Okay, if today is January 15th, it is going to return January 16th. If today is, okay, if my data says January 31st, it should return February 1st. Okay, that's the next day function. So what kind of parameter should this next day take?
No need to have any parameters.
It doesn't take any parameters, right? Because I just call today dot next day. That's it, right? So it would be very nice to write stuff like cout today dot next day. So it doesn't take any parameters. But what kind of parameter, what kind of value should it return? What is the
Another day of
Yeah, it should return another day of year, exactly. Day of year. when you say return a day of year object, it will return it. And I did not overload the stream insertion operator yet, but if it is overloaded, then it will be available there. Or I could say things like day of year next is today dot. It's very convenient now. It already knows where is next day. Okay, next day is here. Okay, good. Okay, so do you want to implement next day? Let's implement next day. Okay, day of year, and day of year. Next day, and 6, right? Was it 6? Oh, no, it is not 7. 7. It is 7. What is 6? Doesn't do anything. So, what should I do now? Okay, I am going to.
You will need another day of year. So
Okay, maybe, yeah, day of year. Let me call it next. Okay, next dot day is equal. Okay, get the value of what? Day plus plus. But when I say day plus plus, if it is 31st and etc., so I am going to just simply assume. Okay, I am going to do this very simple approach. It's going to be day. Okay, it's going to be day plus 1 modulo 30. You like it? Well, I am assuming that all the months are 30 days. Well, I'm just for the sake of simplicity. Okay, so next day that way, and next dot month is going to be what? Month plus, tell me what should I do? Day plus 1 divided by, yeah. So it doesn't work very well. I mean, it will make a mistake for all the months that are not taking 30. Okay. For February, it's going to make a mistake. For January, it's going to make a mistake, etc. But okay, so it's not a complete one. Maybe it's a good example for a stub, right? And I just return what? Return next. Okay, some of you are doing very well, but most of you, your eyes are lost. You don't know what I am doing here. Okay. First one thing is, why are we doing all of this stupid stuff? The second thing is, how does all this stuff work? Okay. Two questions, two stupid things, and you need to learn those two stupid things. Why are we doing? Because we are doing object-oriented programming, and it works this way. You encapsulate. You put your data and you put your functions into the same capsule so that you hid information from the outside world, and your class is self-sufficient. When you declare a day of year, everything comes with the day of year, including the next day, stream insertion, stream extraction, and comparison, etc. All of them, they come. Okay. To be able to do this, you need to learn the syntax. And most of the time when I'm talking here, you make your design decisions at this level. When you are writing this class definition here, okay, your design design decisions comes here. Okay, what should I do now? Okay, this is the two data that I need. Output is something like equals, less than, or day of year, and etc. Right? I can do this. Okay, and after that, I am implementing this, and while implementing it, I need to be careful about syntax, and I need to be careful about the logic too. Okay. In this case, very nice function. It doesn't need anything from the outside world, and I made a simple mistake. Maybe I know how to fix this. Maybe I can put maybe I can put an integer array of month values, right? And do it with this one and 7, 31, 28, 30, 31. Is that how it goes? 30, 31. It goes that way. So instead of doing this modulo 30 month value month, is that a correct logic? Would it work? Month plus 1, yeah, maybe month plus, no, month value, yeah. Yeah, and yeah, well, okay. The rest, I don't know, just you figure this out. It is as simple as something like that, okay? And I figured this out because there is a problem with the next day, but I am very focused about it. I don't talk about the main design decisions of the class. I am talking about the next day functionality. So object-oriented programming techniques makes it easy for you to write programs, but still the main algorithms are there, okay? You have to figure out the main algorithms. The nice thing is that you are not going to get confused about your main algorithms and the decision of the class interface. So this is your problem. This is not customer's problem. The customer simply calls this next day and prints it out or assigns it to somewhere, okay? The customer doesn't know how it works and they don't care about how it works. It becomes your problem now and you don't reflect this to outside world. That's the idea of object-oriented programming. Writing reusable, easy to use classes, okay? So that's what we are going to do, and that's what we are going to talk about every day in the lectures of this course. Okay, it looks like I am running out of time. Are there any questions about this very fast and small introduction to object-oriented programming classes today? Yes?
How do you implement intermediate functions like between two classes? Do you also put them in classes?
What kind of functions, for example, are you talking about? I mean, if there is a function, that function should be about some data, right?
Yes.
So you should do some encapsulation first, and if that function works on that data, you are writing another class then. But you are saying that maybe there are some functions that don't define any data. For example, the function cosine. What would be the class of the cosine, right? Cosine takes or square root. Square root takes a double and returns a double, right? It needs all the data from the parameters. Where am I gonna put this square root function under what kind of class? We will talk about them later. We are not going to use a global function for square root, especially in Java. In C++, as I said, C++ never argues that it's a pure 100% object-oriented language because it has to keep the compatibility with C, right? So it's kind of an object-oriented programming language, but Java says that I am an object-oriented programming language, and we will see the solution of Java for those kind of functions, the functions that you are talking about. Yes, you have a question?
Do we need to write comments in the implementation part of the function because there's no need to check it out?
Do you need to do what?
Write comments.
Sure, yeah. Why are we writing comments?
Introducing the function, introducing the...
I mean, who reads the comments? We read the comments ourselves, right? If you are talking about writing the comments for your customers, yeah, you put your customer comments here because your customer is going to see only this part. They will not see the implementation. But in your implementation part, there should be many details about your algorithm decisions, okay, your implementation decisions, your to-do things. So, I mean, comments, you always write your comments for all types of code. As long as you are writing them, you should write your comments. Okay, good. Any other questions? Okay, do this. Okay, write this day of year class yourself without looking at these your book or the slides or the video, and add some more functions. For example, I did not implement this less than function, right? And write other functions like what do you do with the dates? I don't know. Next day I already did that, or maybe write this one. What is the difference between two day of year dates in terms of days? How many days are there between January 25th and June 15th? Okay, write that function. So make a decision about the function header. What kind of function header I should have? What kind of name should I have? It's like an subtraction stuff, right? Okay. Another function would be just the opposite. Okay. How many days are there between January 1st and June 5th, etc. So what day of year is June 5th? Is it 150 or 270, etc.? Okay, write those kind of functions for this day of year, and you will get used to it. As I said before, if you did not write such code before, you will get confused, especially with the syntax. There are two things, there are two ways that you can get confused. You will get confused about your design decisions here. Where does the data come from? That's one thing. The other thing is when you are implementing stuff, these kind of things will get confused. And when you test them, you will be fine, you will see. In a few tries, you will get used to it. Okay, I'll see you tomorrow then. If there are no questions. Sure. Okay, you want to ask question? Who is talking?
Should you avoid using single line commenting?
You should avoid. You should avoid using what?
The single line comment in assignments. Should we avoid it?
No, why not? I mean, single line comments are perfectly valid comments for C++, and you should always. I mean, if it says single line comment, use those slash stuff. I don't know why you are asking this.
Because of the I don't know, reusability of the code, maybe compile it.
Well, your sound is breaking up. I don't know. I mean, ask this question maybe tomorrow again. I am not understanding your entire question. And I understand it, but I don't know why you are asking this.
Hocam vize sınavının ne zaman olacağı hakkında bilgi var mı şu an?
Ne sınavının?
Vize sınavı.
Syllabus'a ne yazmıştık?
8 Kasım.